Welcome to the World Sleep Day. My name is Michel Billiard, and I am a professor of neurology at the University Hospital in Montpellier, France, and a former president of the European Sleep Research Society. Narcolepsy is a fascinating disorder. The first description of narcolepsy was in 1897 by Westphal, a neurologist in Berlin, who published the case of a man who had sudden attacks of sleep and language and motor inability. 3 years later, Gélineau, a physician in Paris, described the case of a wine barrel merchant who, from the age of 36, had sudden attacks of sleep and, on strong emotions, falls on the floor. And Gélineau coined the word narcolepsy from the Greek narcos, sleep, and lambenein, to size. In 1934, Daniels, an American physician, identified 4 symptoms in narcolepsy: excessive daytime sleepiness and cataplexy, and 2 auxiliary ones, hypnagogic hallucination and sleep paralysis. Excessive daytime sleepiness occurs every day, and it culminates into irresistible sleep episode. Cataplexy is a loss of muscle tone triggered by strong emotions like a compliment or a fit of laughter, or for the hunter seeing a prey, or for an angler the perception of a fish beating at the hook. This is a very incapacitating symptoms. Well, the frequency of cataplexy is extremely variable. It can go from 1 or 2 per year to several per day, and the duration of cataplexy goes from a split second to several minutes. Hypnagogic hallucinations and sleep paralysis are inconstant, and they are unpleasant, but they are not much of a problem. The prevalence of narcolepsy is not at all exceptional. A lot of surveys have been done, and it turns out that the prevalence is between 20 and 50 per 100 people, 100,000 people. That is 200 to 500 in a 1 million inhabitant town. Well, the pathophysiology was totally unknown at first, and then step by step it was progressively unveiled. The first step was definitely the discovery of rapid eye movement sleep, the so-called REM sleep, in 1953, and 7 years later the discovery by Vogel that narcoleptic patients falls asleep directly into REM sleep, whereas a normal subject always falls asleep in non-REM sleep. And from this, it was thought that everything was explained, because cataplexy and sleep paralysis are the inhibition of REM sleep, and hypnagogic hallucination are sort of dreams occurring during these when they fall asleep into REM sleep. The second step was the discovery of a natural animal model of narcolepsy, first in Dachshund, then in Poodle, and then in other breeds like Doberman and Labrador. And this enabled a series of tests, of pharmacological tests, and it was discovered that the pharmacological control of both symptoms was not the same, and the pharmacological control was dopaminergic for excessive daytime sleepiness and noradrenergic for cataplexy. The third step was the demonstration by Japanese psychiatrist Yukata Honda in 1983-84 of a striking association between HLA DQ1 DR2 and narcolepsy in Japanese narcolepsy cataplexy patients, and later on Dr. Mignot in Stanford found that at the molecular level the association was with DRB1 1501, DQB1 0602. This association was thought to represent a virtually necessary condition to have narcolepsy, but not a sufficient one, as 20 to 25% of normal controls do have the same haplotype. More recently, in 1999, the discovery by Dr. Emmanuel Mignot's group in Stanford of a striking of a mutation in the gene coding for the hypocretin type 2 receptor in the canine familial model of narcolepsy in Labrador, and then it was shown that the best biological marker for narcolepsy with cataplexy in humans is the significantly reduced or undetectable level of hypocretin 1 in the cerebrospinal fluid of almost all DQB10602 positive narcolepsy with cataplexy patients. This finding, together with the association with HLA and the onset of the condition at the prepubertal age, and the selective loss of hypocretin neurons in the lateral hypothalamus on narcoleptic brains, brought the suggestion that narcolepsy could be an autoimmune disorder. Well, for several years, available data did not provide a strong support to this concept until the group of Mehdi Tafti in Lausanne, Switzerland, last year reported the identification of circulating anti-type 2 antibodies reactive with hypocretin neurons, confirming the autoimmune nature of narcolepsy. So the saga is certainly not over, but one can measure the extraordinary advances in the understanding of narcolepsy, and it is our hope that new treatments based on this pathophysiology will emerge in the near future.